All right, let's get going. All right, welcome back. We are game 3004 in the winter 2021 semester at George Brown, and it's week 12, part 2 of our broadcast. First part was kind of a project update like normal, and the second part is going to be our lab. So what are we doing with our lab? This week we're going to do some stuff with animation again and convert our project to the URP and make a little shader with shader graph, as well as test everything on our native devices. So let's get going. We have a starter that we normally have. Let me see if this is actually going to work now. Yay! Here it is. There we go. So there's the video for today. Awesome. And our starter is just the previous version of the game, just this one here, 11B final. So I've already taken the liberty of downloading that for myself, which I've got right here. Right, you guys can do the same. I'm just going to expand this one and unzip it. You can see it's massive when I do so. Why? If you remember last week, what we did was we added all the animations, right, to the project, and it was pretty big. So we're going to fix that this week. Michael says, can I use my lab from last week? Yes, you can. And what I had to do is use large file support, and later on I got this message from GitHub that said, you've gone outside of the range of large file support for your account. We like you, but you have to pay $5 if you want to have this many. You're way outside the range. And I'm like, okay. So I kind of paid $5 for George Brown, and now I have large file support, a little bit more packages. And that's totally fine. You can arrange that, by the way, on your account pages. But yeah, so that's what we did. So there's 12B. I'm going to bring the README file up just before we start the GitHub repo. And in fact, one thing I want to do with the whole, so this is lab 8 final. So we're going to put up. One thing we need to do for this package that we're going to do is I'm not going to put it up on GitHub until I remove stuff because it doesn't make sense. It's like, it's massive. It's huge, right? So let's start off with Unity Hub. Let's get that Unity Hub going. And I'm going to add an existing package. So it's going to be this 12B. And you're going to see it's going to spin out, and it's going to take time for it to kind of open up. So let's see how this works. I encourage you to get the same thing open up from your side. And when I'm ready, I'm going to put this up on GitHub, and then you'll have your final version in a bit. So we need to optimize. One of the things we want to try and do whenever we make something for mobile is reduce file sizes, because remember, your entire package will be made for your device, and we'll look at what the package size is going to be in the builds folder when we're done. The APK is what we're going to look at. Remember, the bigger the APK, less likely someone wants to download it and keep it right later on when you upload it to an Android device or sideload it or whatever you're going to do. And similarly for an iOS device if you were going to develop for iOS. So let's wait until this thing. You can see that this is going to take quite a bit of time. Oh, I did not. Thank you for that. I'll switch back from video optimization. Thank you. That should be an improvement there. How's that? But the video is okay. All right, so yeah, it's a weird thing that does. So you can see it takes time, and one of the biggest things that it's doing is it's trying to open up the project to convert everything. So there's my project, and let's go into our scenes. So we're going to take it into the test scene this time around. So my test scene has this little guy here, right? And this little alien-looking zombie we kind of made last week, he has this little marker. We're going to hide the marker for a second. So we're just going to turn that off. And one of the things we talked about was like, well, how do you make the animations go? So if I was to run this the way it is, just as is, in the scene, you can see that without optimizing, we're going to get this guy. and he's got some issues. Let's fix the issues first. So one of the issues that he has is some of the scripts aren't working properly. So let's get those scripts fixed before we fix anything else. And the scripts aren't working properly because things are missing from this scene in our test scene. And we don't want ever, when we have a test scene, just by chance to fail. So he's trying to look at something that doesn't exist. There is no player because that's where the player gets the world camera. So let's fix this. So world camera, that's based off the player camera. So a couple things. We're going to say that if the player camera exists, right? If the player camera exists, one day when my ReSharper C++ and ReSharper works, then we'll have some responsiveness. Only if the player camera exists, then what we want to say is that we want to make the world camera. That's number one. And we only want to reposition everything if the world camera exists here as well. So we don't want to like billboard if there's no world camera. So let's just do that. So that's just the one little bug that we had and we didn't care about because we just wanted this as a test scene, but now we have our little health bar and we don't want it to error out. So that's why this fixed this. It just changed this part. Nice, nice. And that'll take away some of these errors. And when we run it again here in our scene, we should be able to see our little guy march. Yay. But the problem is now we see that little marker. I don't want that marker. So going to the main camera and make sure that main camera in our test scene, we get rid of our marker. There we go. And then if we run, we will march. There we go. Michael says, do we need the health canvas camera to be in the if statement as well? Nah, it's okay. You mean in here? Health camera, this one? It's not giving me an error, so I mean it's okay. But it is using the world cam, isn't it? I guess it has to be. It's probably a safe thing to do. All right, there we go. Again, not a big deal. This is not the focus of our day today, but I wanted to just take away any kind of errors. All right, so that's cool. We know it's working now because we can march along. We can see our little guy do his thing. Yay, that's pretty cool. Excellent. But now what we want to do is we want to think about optimizations. And remember that each of these files in our animations folder, in our zombie animations, they're massive. They're each like 100 megabytes. And all we really need is the T-pose. That's what the idea is. The T-pose gives us everything we need for the zombie, as an example, and it gives us the armature as well as the materials and everything else. So what we want to do is, out of all of these things, we want to remove or expose the clip. All right, so what I'm going to do here is I'm going to go do this. I'm going to say running. Let's do a Control D on the running clip. Let's do a Control D on the punching clip. Let's do a Control D on the jumping clip. Let's do a Control D on the idle clip, and so on. I'm just duplicating these. So these are all the animation clips, 1, 2, 3, 4, 5, 6. And now let's get rid of the animations, which are the bulk of the code. So let's get rid of that, delete. But actually, before we delete those, sorry, we should fix the animator, right? Because the animator in our zombie, here's the animator controller, it's pointing to the other clips, right? These ones. So let's make sure that the animator points to the new clips. So again, when we look at dying, it's going to point to the dying clip, this one, the new one. The jumping, it's going to point to this jumping clip. Running is going to point to the new running clip. I'm just making the new associations. Punching is going to point to the punching clip. And idle is going to point to the idle clip. And now, once we've done that, we can get rid of these ones. Not that it would change anything in here, but it just would break, right? So we don't want that to break. And if we run it, we should be able to see everything work as normal. Yay! And we just saved, I don't know, 600 megabytes or more of data. So that is huge, guys. 600 megabytes removed from our project just by removing animations, right? Which is a really good thing. So these are the animations. I put them in a clip folder last time, but I think it's good just like this. I'm okay with it like this too, because it is these zombie animations and they're right there. And we care about the T-pose. This is the prefab, but these are important to put in. So that's all we need. Now let's put this up on GitHub. But first, let us transfer my settings. So we'll go to build settings. We'll choose Android and we'll switch platforms. And let's do all that switching stuff. So I might spark out here for a second, as my video card works very hard to convert. And once everything converts over to or we switch platforms from a desktop to Android, then make sure that you can see your devices. I have two. One of them is going to be my emulator. The other one is my actual device I'm going to test on. I want to go to player settings before I move on and change this so that it says lab 8. We didn't deploy last week. And for obvious reasons, we were still working on getting all the animations going, ran out of time. But this week we're going to do that. So there we go. And we're going to save. And I'm not going to deploy yet. I'm going to save this and push this up on GitHub. So let's see how that looks. So I'm going to save. So file, save scene, file, save project. I'm going to close off Unity. I'm going to kick off our command prompt, which is right here. And what I want to do while Unity is doing its closing dance is I want to bring up our package. And I'm going to go into, let's wait for Unity to do its thing. I think Unity is still, do I have two versions of Unity open? Oh my God, that is pretty bad. I shouldn't have two versions of Unity open at all, ever. I wonder it's taking a long time. Yep, it's doing its application quit stuff. Yay, okay, cool. Then I can do a CD space, just like normal. Or you can use your favorite GitHub tool and do one of those, and then do the same thing we normally do, which is git init, git add dot, and then git commit -m, and we'll say initial commit. Now, one thing we have is a git attributes file that's in here, and the git attributes file allows large file support. But let's see what happens. Do I have to do that whole process again that we did last week? So again, I'm going to go up here. I'm going to make a new project. And we're going to call this GAME3004 in the winter 2021 semester. And it's going to be week 12. Or do we call this, what did we call this last time? Sorry, let me just grab this for a second. And just going to make sure, yeah, I call it week 12B final. Week 12B final. There it is. And I'm going to grab these lines of code. But one thing I noticed last time is when we wanted large file support, we had to turn it on. So when you skip down here, I don't know if you guys remember, but there was a setting for large file support objects. So one thing we should do is turn that on. I have one, and that large file support object is going to be, that one T-pose animation. Now, because I've included it in the archive, the great thing about this is GitHub uses the same archive for the same file, so it won't charge me twice for this stuff, typically. But just to make sure, I'm clicking it on anyway, just so I don't have any problems. I'm going to go back to my code here, grab the last 3 lines of code, and then copy them, and go to here and right click, and then let's see if it fails this time around. So again, shouldn't. Let's see what happens. So it does this. It's looking at uploading large file size objects. It's doing that. It did that part first, right? And then it should work. So we have one large file size object that adds to our archive, right? And I got an email. I wonder if I got an email about this. Did it take me out of quota again? It just might have. No, still good. All right, it looks like we're good. We put this up on GitHub, and there's only one large file object that's in there, one LFS, and that's from last week. Again, you may have to do LFS stuff for yourself if you have large textures, those kind of things, or anything else like I have in here. But again, the upload is really small compared to last time. Look, 119 megs overall, not a big file, and I'm pretty happy with what we just did. Great. Let's refresh. And you can see that, this went up nicely, no issues, right? So what about that archive? Where is that thing? So again, see if I can show it to you. Repository topics. We'll do it later. I want to move on. But anyways, it gives you, hopefully you went through it too, and you saw that there was a, from a large files perspective, you had it there. One thing I need to do is I need to put that new file up as a final. So I'm going to copy this one, and I'm going to go to here, our content, and I'm going to add that web link. So we'll say that this is the Lab 8 final, right? That's our tool link for that. And that'll give you a place to compare my code with your code, worst case scenario. All right, fantastic. I've pulled up Unity. I'm back to this point. Hopefully you guys are back there with me. One thing I need to do is change my game from game to the simulator, because we're going to simulate this here. So I'm going to go and select the right device as normal. So it's going to be Samsung Galaxy S10 Plus. Move over here, turn the safe area on so I can see what it looks like. And when I run it now, I should be able to see a preview of what it's going to look like in the on the screen. Okay. All right. What I want to do now is I want to push my game with my we never tried this last week, with my animations on my device. So let's do that now. I'm going to bring up LDPlayer. Here's LDPlayer. I've already got that going on, and I've already got this up. This is my actual device. So first I'm going to try on my device, and then I'm going to, or my emulator, then on my device proper. So I'm going to go to the actual scenes. I'm going to go to scenes. I'm going to go to main. Here's my main scene, and I'm going to go file, save, and then I want to build and run. I'm going to create a new folder like we've done many times called builds, and I'm going to kind of go in there and go Android builds, and then Android. There we go, and then click save. And what I want to do once this is done is I want to compare the file size. Okay, here's an error. I want to compare the file sizes. So where is this error coming from? It says that assets enemy behavior is an issue. Why is that an issue? Because I have this extra using statement that I don't need. Sorry, I forgot to remove that one. That was inside of my enemy behavior. I think it was added because I added an animation controller as opposed to an animator controller last week. And we never had a chance to build, so we didn't know that. Okay, let's move back and try it again. So again, just clear that up. And let's try it again. So it's not a big deal. File, build and run, and it should work now. I'm going to spark out here, guys. So if you lag, to on YouTube, I recommend. And again, we're just going to wait till this is done. Like I said, 3070. So I can only imagine what this is doing to other people. Hopefully your system won't crash. I had a crash earlier today. One of our students crashed out. His system kind of rebooted completely. All right. And this is part of mobile development. Mobile development, you need a pretty decent computer to do it properly. Do I still sound worse than R2D2? Maybe. It's probably because I'm using NVIDIA Broadcast. All right, so now it's transferring the package, and all I'm looking for is to see that this package works on my player. All right, let's see it's which player it's chosen to go on. So is it chosen to go on which device? Now, here's something I know, it's not on this. So chances are what's happened is it's gone on this because it kind of deployed somewhere, right? And sure enough, actually, instead of making it on the emulator, it's actually on the device. Look at that. So that's pretty cool, right? So on my device, it's working okay. Shadows, not really that happy with the shadow quality right now, but that we know that that is an issue with devices. Let's turn on the little mini map, and hey, look at that. By the way, I fixed my issue with billboarding these guys, and I'll talk about that little code later on. All right, so there we are, and so it looks okay, and the animation on a mobile device is pretty good, right? On a little device, right? That's what's happening right here. All right, so that's good. Thank you very much for that. Frame rate's not so degraded either, looking pretty good. Again, for only a small game like this. All right, so what about now that we've got that tested and everything else, we tested it physically on the device, which is even better than the emulator. That's why it took maybe so long. That's good. I like that. That's awesome. But let's talk about some other things. One thing is, let me talk about my enemy behavior and what I did for billboarding really quickly. So we're having a problem billboarding, and I was looking at it, and the way I figured it out was something that looks like this. So I have this new function called LDPlayer. And what I did was I did a rotation, which is a quaternion rotation. So I kind of set that up. And I said, let's take a look at the player transform position minus the transform position of the enemy. Because remember, this is the enemy behavior. So we're getting the direction. That's what this is. The direction from the player to the enemy, right? I convert that to Euler angles, and I set the rotation of the X and Z components to 0, and then I just do a transform rotation to that, and that works great because I'm not affecting the X and Z components, and that's what caused me to rock back and forth on my heels when I did a rotation.lookAt, which was not right. So that looks better. Okay, so that's my little piece of code that we didn't have last week. Okay, good. So that is that. And now I want to think about converting. I want to use a custom shader. And so here's what I want to do. Let's move back to my scene view, and let's get into my my test scene again. So in my test scene right now, I have this little guy, right? My little zombie, and I want to create a glow effect, right? And let's suppose I want to make a glowing pillar, something that I want you guys to look at all the time. or some kind of custom glow effect or any custom shader. We have a model for this. I'm going to bring in a model. It is my pillar model inside of my resources prefabs pillar. Let's bring that in. So there's my pillar, right? Let's put it behind our little dude, right? And we'll rotate it a little bit so we can actually see it in, I don't know, the corner, which looks more interesting than just like looking at the actual pillar. And so it's kind of a backdrop to this guy, so we can see it in different angles as well. And when we look at it from the simulator, then it's going to look like this. Let's bring up our camera just a touch in the scene. So in the main camera, all right, and the scene main camera, we're going to bring it up just a touch so I can see this. I'm also going to rotate the main camera just a bit, just so that way we can bring it up further. And I'm just going to, I think that might be good actually. So we can see the most of the guy and the pillar in the background inside the simulator. Okay, this is pretty cool. So that's what it's going to look like in our test scene. So what I want to do is I want to take this pillar, and the pillar that we have right now that's inside the scene, I want to unpack it completely. So let's just make our own little pillar. And what I want to do is inside of my materials for the pillar, I want to make a new pillar material. So I'm going to duplicate the one that I already have, Control D, and I'm going to call that material pillar material. Really exciting and original. And what I want to do is the pillar itself is I want to use the new pillar material that I just created instead of the default one that we have, just drag and dropping. So we don't affect the original pillar. Just in case this whole process fails, this is a good thing to do. And in my pillar material, here's my pillar material. I just want to, I have a bunch of things here. I have albedo, I have roughness, kind of an input for roughness. I have a normal map and a height map, both those two things in there, as well as ambient occlusion. I want to see if I can include a lot of this on my own. And it's also using a metallic rendering mode, all right, for this as well. So this is all the stuff that I want to duplicate or replicate with my own shader. That's what I want to do. I was going to make my own shader now. All right, so that's what I want to do. That's my scope, if you will. And but first, before we use shader graph, because that's my idea, let's use shader graph to do this. We need to convert our project to URP, Universal Render Pipeline. How do we do that? Well, let's go into our window. And if we go into Package Manager, we're going to go to the Unity registry for URP. And if we're going to scroll all the way down, you're going to see Universal Render Pipeline right here. And I want to click Install. Now, just installing the URP isn't going to make any changes. And why didn't we start with the URP from the beginning, you might ask? Well, there's a couple of issues with this. URP does add a lot of bandwidth, and some parts of the URP, just adding it to a WebGL scene adds reduces frame rate just by adding the URP to your project. WebGL 2 handles it okay when we did it earlier this semester, but there's some issues with it. And the other thing is I wanted you to create stuff unfettered, so I didn't want you to be limited just to shaders that are compatible with the URP. And so that's why I kind of held off from converting our project earlier on. I knew this is what I wanted to do, but I didn't do that because I was like, you know what, I gotta hold off here. I want to see how things go. And so before I convert, that's why I'm doing this. So now you can see that it's installing, just reserializing some assets that it's bringing in. It's not changing anything though, so be aware of that. It's not changing your shaders or anything like that. It's just installing the package. When you install URP, automatically you get shader graph for free. So that comes with URP. Notice that they're the same version, 10.22, because they're kind of linked together, right? All right, good. We've installed our package, but we haven't configured it yet. What I want you guys to do is two things. I want you to create a new folder. We're going to make a new folder here called URP Assets. And inside of our URP Assets, this is where we're going to install our pipeline. So the way to do the pipeline, no problem. Michael says, wait, just wait a little bit. I'm okay with waiting. So I'm also looking up online for any questions. Are you ready, Michael? Is that the thank you, or thank you for waiting? All right. Yeah, so what you want to do is you want to install the URP assets. So the way to do that is to go into, okay, good, assets, and I want to create, you can go do it this way as well. And I want to go down to where it says rendering. Under URP, you want to create a pipeline asset for a render. This one, first thing, okay? Then click it. It's going to make the asset, and it's going to make two of them. There's two assets. One is the pipeline asset itself, and the other one is the renderer. You need both. There's two little assets it'll create for you automatically. Okay. Now, so far, so good. Yes, we like the asset, you might say, but this isn't the end. We have to configure our project, and we're going to go into File, or sorry, Edit. We're going to go to Project Settings. And under our project settings, we're going to select Graphics. And where it says None Render Pipeline Asset, we're going to click this little target. We're going to click our new Universal Render Pipeline Asset. And then you're going to see all of our shaders turn pink, like this. Except, oddly enough, for our health bar asset. But everything else is going to be pink like this. This is a good sign. This means that we've switched our rendering model, and we need to switch up or upgrade our shaders, our current shaders. Now, warning, if you have downloaded shaders from another package on the asset store and you try and do this, it's at your own risk because it may not work. Okay, I'm just letting you know, because some of those shaders are not standard shaders. This will easily update standard shaders to URP, but not some of the new ones. So unless your package is rated for URP use from the asset store, you may have to replace some of your shaders and materials on your own. Okay, I'm going to go into File, and notice, sorry, under Edit, I'm going to go down all the way to Render Pipeline. And under Render Pipeline, I want to do two things. Generate Shader Includes. And then I want to do that again. And I want to go down to Render Pipeline and go Universal Render Pipeline. It says Upgrade with Project Materials to Universal Render Pipeline Materials. Click the first one. And then click and let it go. It's going to try and do its best to convert whatever shaders you have, right, to the new materials. And notice it completely failed on mine because all of my shaders, right, as an example, are custom shaders. Yours may have worked fine for you. Mine did not. So what happens if this happens to you? Is all hope lost? No. And this is okay. I'm actually glad this happened to me. It didn't happen to me the first time. Again, if I go back and I look at Render Pipeline and I go, I want to upgrade my project materials, again, and it tells me to proceed, sometimes the second round it'll work, okay? So this is what it looks like. But if you have to do it manually, like example, my floor, right, which is my ground uses a default material that's from Unity. Any default materials from Unity itself, you have to actually kind of point to something else. So I have a material we can use. If you point to the ground material, I already have a ground material, please point to that. And then it'll look like this. Okay, so let's save that. And let's see what my scene looks like, not here, but in my actual scene itself. So if I go into scenes, and if I go to main, so I've saved my scene, go into main, and if I look at my materials in main, you should see that most of the materials are looking okay. Okay, most materials look just fine. I don't see any kind of materials that are, as an example, looking pink, which is not what we want. Okay, pink materials bad. And as well, notice that, let me go back to my test scene now. Notice that when we look at our zombie, here he is, it doesn't matter. His health bar looks okay from the get-go. So we've upgraded our materials. We have our universal render pipeline working, and now I want to add a new shader. So let's go into our shaders folder, which I already have for you. And I want to right click here, and I want to go create. I want to go shader, and I want to choose under universal render pipeline, a lit shader graph. That's what I want, a lit shader graph. Okay. And I want to call this the pillar shader, and press enter. The pillar shader is our new asset that it got created. I want to double click on it to engage the shader graph component. So double clicking brings up this window. And I'm just going to make a little bit more room. One thing that I noticed is my little preview doesn't show me anything of value. It shows me this little sphere. I don't want to see a sphere. I want to see my pillar, so we can compare what it's going to look like when I'm creating my shader, right? So what you can do is if you right click, and if you look at custom mesh, you can choose the mesh you want to target with your shader. I want to target my pillar. So when I get my pillar, then I can rotate it, and you can see what the pillar is going to look like in the scene. All right. So again, I like to kind of have a representation in here of what it's going to look like, you know, as an example, so I can compare what I'm doing and make sure that it makes sense. One thing to note is in Shader Graph, what you have is a brand new window that, if you've never used Shader Graph before, will look foreign to you. But you should be recognizing a couple things. First of all, if I drag anywhere on the scene, in this area here, this is the blackboard, if you will. If I drag anywhere in here, I can highlight stuff and move them around, right? I can use the same controls. So if I use the middle mouse button, I can move everything around, pan it around the scene. I can zoom in and out with my scroll wheel. These are all things we can do within the interface. Things that I will call your attention to is on the left, there's something called the properties panel. You can add new properties here. On the right, there's the graph inspector. And notice right now we have a vertex shader and a fragment shader. And that's normally how we work, through the rasterizer, cross the rasterizer into the fragment shader. We have some stuff in the vertex shader we're not touching, okay, right now. We're not touching the pipeline before the rasterizer. It's after the rasterizer into the fragment shader that we're touching, okay, right now. The precision, we can change from single to half if you really want to. We're not going to do that. And the target, active targets is universal. That's the target we're working with. Material, you have a chance to choose the type of material you're making. Notice that there is lit or unlit, depending on the type of material you want. I want it to be lit. Workflow, do I want metallic or specular, right? And what do I want my surface? Do I want it opaque or transparent? I want to choose transparent for sure. That's going to add more information in here into my my shader, okay? Fragment, normal space, there's normal, object, or world. I'm going to use tangent. Leave it as tangent. I'm also going to go, this is actually going to modify, it's almost like creating a BSDF, a principal BSDF kind of a shader is what we're going to try and go for as much as possible, right? So here, instead of it being metallic, a lot of times I use specular. And if you do that, it changes up the channels. It adds ambient occlusion. So if I take away that, so notice I have a specular color here, as well as a normal and a bunch of other stuff. These are things I want to expose in my shader itself, okay? So again, if I go back to metallic gets added, ambient occlusions is still there, but all it does is swap out metallic for specular. So if I go back, look, it's all that gets swapped out, specular for metallic. It really depends on what you want. I'm going to leave it metallic for now. So that is your fragment, and this is what we're going to work with. These inputs, these channels are the things that we're going to work, just like we did in Blender, to kind of make connections to, little nodes. Okay, but before we go there, what I want to do is I want to go over into our materials, and I want to take my pillar material, right? And right now it's using the universal render pipeline, and it's using the Autodesk Interactive material. I don't want to use that anymore. Instead, I want to go into shader graphs, and I want to use our pillar shader right here, which is going to make it look like this. Notice what I see here is very little, if anything. If I click Save Assets, it's not going to change anything here. Okay, just letting you know. No change. But inside of our scene, we can see that this pillar has just become something that looks like it's transparent. Okay, why? Because we chose a bit of transparency. We chose that, right? So what does that mean? That means if I add another asset, so let's just add anything to the scene. So if I go back to our scene here, and I want to add in a 3D object cube, and I put it behind the pillar, right? Not in the pillar, behind the pillar, right? Then do we see it? Well, the answer is kind of yes, right? It's kind of there, right? And we can see that there is a shadow of what it is inside. I'm leaving the cube there just for just so we can see what happens with our shader as we continue to work. Okay. So this is kind of an occluded material. That's all it is. Awesome. I like it. We're going to get back to this. All right, let's get back into our pillar shader and start working. So nice. We have our material, which is our pillar material. I want to see this open all the time when we're working. We can compress this a little bit to give us more real estate as we continue. And what I want to do is I want to put these right up to the top and make it a little bit smaller so I can start adding in some stuff. Okay, so what I want to do is I want to have this Fresnel effect, right? And the Fresnel effect is like an outline, right? So that's what it kind of does. And it's a very popular way of starting to learn about shader graph. And there's a couple ways to add something. If I right click here, I can create a node, or I can also press space. Space is actually really quick. So press space, and if I look at Fresnel, I can look at a Fresnel effect. And what a Fresnel effect does is it creates this I don't know, edge of glow, a glowy edge. All right. So if I take the output, notice the output says 1 and the power says 1, but the normal and the view direction says 3. These are vector 3s. This is a vector 1 or a float. That's what it is. And over here, it also tells you the inputs over here. This takes a vector 3 in tangent space. This is smoothness, which is a float, vector 3, float, float, float. Okay? So that is how it works, just to let you know. And what I can do is I can take the output from the Fresnel effect and drop it right into the emission property right here. And we can see that all of a sudden it becomes kind of glowy, white, right? That's what it does. That's the effect of the material. No effect here, but it does affect this. Okay, so if I was to save the asset, immediately you see the effect on our pillar material. And if I go back to the scene, you can see that the pillar material becomes slightly shiny. Good thing is, I can hardly see the thing behind it, right? We're going to get to that. Back to the pillar shader. All right, cool. So I've got my base color and I've got a bunch of other stuff, and this is good, but I would love to have my Fresnel effect have maybe another color. And so I can add a color to it by using multiplier. So I'm just going to go out, put this over here, move this over here, zoom in so you can see it. And I want to add another color. So again, down somewhere in the blackboard down here, I'm going to press space and then pull up color. And I'm going to just choose basic color, this one. And my basic color right now is black. I'm going to choose, instead of a default mode, I'm going to choose HDR to give myself more range. And I want to combine this color here, whatever I choose. Let's choose a color like yellow. There's my yellow color, right? I want to choose a color like yellow, and notice that the I'm looking at HSV. We can also choose RGB, right? You can see that our RGB values are 255, 233, and an alpha transparency of 0. We can bring that right up to 255, right, which makes it completely solid yellow. Okay. We can change this later on, but let's make it solid yellow. All right. And what I want to do with the solid yellow color is combine it with the Fresnel and kind of put it into the emission slot. So the way to do that is to go here, remove the line by clicking on it and clicking delete. And then what I want is a multiplier. So again, spacebar, I want to talk multiply. And multiply gives us two inputs, A and B, and it kind of combines the effect. So I take this output here. Notice the color is the same. I take this output here, put it in here, and now we have a combined effect. All right. And then from here, what I can do is I can take this output from here, and it goes nicely into the emission over here. And when we save our shader, then we can see the effect immediately on our model. All right. So if I go back to the scene, we can see that the model is now yellow completely. Okay. Nice. You're not going to be impressed yet. Let's change the power of this thing to something like 3. And what the higher power value, it reduces the Fresnel effect, the amount of yellow that is, and it increases the amount of the base color in the middle. Right, that's what it does. So I can save that asset, and you can see now that you have kind of a base color value that's gray here, and then the yellow color that's outside of it there. And if I go back to the scene, then you should be able to see that there's a kind of a glow around this thing. And it's emissive. Let's make it really much more pronounced. And the way to do that is to go back in here, and we can increase the HDR value here to some other value. Let's go move the intensity from a 0 to, let's say, a 3. Okay, so there's a much more intense color value, right? So much more glowy. And what I can do is I can say save that asset, so you can see that the effect is going to be here. If I go back to the scene, it's going to feel even more glowy than normal. But again, it's how you perceive it. The way to best see this is to have a base color that's not gray. So let's change our base color to something else. So going back to the pillar scene, and what I want to do is this base color here, I want to change it to something else. So let's move it to something like a contrasting color, like blue. Right? So blue color, we'll make it all blue, no green. So really, really blue, and very simple. And we'll apply the change by saving the asset. We'll see something that looks like this. Much more contrast. And when we go back to the scene, again, you can see kind of a glowy area here and here, but blue in the middle. So that kind of effect. Okay. So far, so good. And you see the effect. It kind of gives you a preview of the effect here, so we don't have to keep going back and forth. Not really what we're looking for, right? Not really. Why? Well, we have some alpha, right? Our alpha is like, it says 1, and we have metallic, as well as an ambient occlusion channel smoothness, that's 0.5, which is quite, kind of shiny, if you will, and other things. Let's continue with this, though. So this is nice, but the problem is, wouldn't it be nice if I had control of the color? Because right now, if you look at the shader, I got no control. And every single time I want to change the shader, it's internal. No, that's no good. We want to be able to change the shader right through the material. So to expose elements or properties in the material, then we can right-click on a property like color, and I can go to convert to property. What this does is it converts to a property that appears here. I can right-click and rename, and I can call this property, which is the color, the emissive color. So we'll call this emissive color. And then if I save my asset, then you'll see that it'll pop up here. This gives us a chance to modify values. like making this public. That's kind of what we did when we put it over here. By the way, you can add properties on your own here and connect them in different ways as well. It's up to you. Okay? We'll get into that in a bit. All right, so that's the first thing. Second thing is, once we have this emissive property, it's cool, but it'd be really nice if maybe we had a chance to make it maybe glow by pulsing. I want to make it, give it a pulsing effect or something like that. Okay, again, very common effect that we can add in. And how can we add that in? Well, we want to have some kind of time-dependent function that combines with our color to kind of show and hide the glow so that it can highlight the object. That's why I want to show this here. I want this to be kind of showing and hiding the glowy effect over time. So in order for us to do that, we need another node. I'm going to call this the time node. And here's our time node down in here. And what I want to do is I want to do another multiplication. So here's our multiply node up here. I want to take this time node and this multiply node and multiply it again by something else. Let's get another multiply node. Here's another multiply node. And we want to get rid of this line. Okay. And I want to combine the output from the current way it's looking into the input for the multiply node. And I want to use a sine time-dependent function. You can use sine or cosine if you want. And I want to get the sine function and push this into there. Now, if I did this directly, you're going to see that it starts to give you a preview of what it's looking like. But it goes from -1 to 1. That's what sine does, right? -1 to 1. And we learned that in physics. So instead of doing a -1 to 1, we want to clamp it, right? We want to clamp it down, or what we can do is we can use a remap function to remap it from 0 to 1. So let's remove that. And let's put something between the time and the multiplier, which is called the remap function. Remap, we have an input, so we go from sine into our input. There's our input. And notice it goes from, this is what it goes from, the top one, -1 to 1, to 0 to 1. That's our remap function. And I don't want to make it 0. Let's go from 0.1 because I never want the effect to completely go away. And then I can take that and drag it into this. Now we have a glowy effect. You can see that this is the stable effect. This is the multiplier. This combines the time that turns on and off stuff into the glowy effect. And I can take this part and I can put this into the emissive value directly. And now we're going to have a glowy effect happen here where it turns off and it turns back on again. And let's save the asset and preview the effect here, right? So as it turns on and off, it's going to do that according to time. But there's not much control here. And what I'd like to do is I want to have some values. So maybe 0.1 isn't the right thing. Maybe I only want to go 0.5. So only half is glowy, as an example, or something else. So I want to be able to get this minimum value or talk about the minimum amount or the ramp or whatever you want to call it from 0 to 100, the percentage as an example of glow, right, that I want to use. So I can make this into a variable. And the way to do that is to create a new node and I can make a new float, right, because it's a single node. X is just a float. And I can basically, I want to make the float come into there, right? That's what I want to do. But notice that it says that this is 0 out and it says max 2. Man, that means I need a vec2. That's okay. So let's put a vec2 in there, vector 2. And let's try that again, vector 2. Click, Tom, click. And then I can take this vector 2 out and put it into there. And I know that the y value is always going to be 1, but the minimum value is something I want to modify. I have control of this float now as part of this vec2. Otherwise, I wouldn't be able to connect to this one because it needs a vec2. So I can go from, let's say, 0.2. Let's use that value as the minimum value for now. And I can take this float, right-click onto it, and go to Convert to Property. And you're going to see that that float I can convert, and I can say that that is the think about this as the percentage or the amount of, fade. How much do I want to fade? Do I want to fade all the way to black? The minimum amount of glow. That's what it is. So I can rename that as minimum glow, right? That's what it looks like. And I want to save the asset so I can kind of expose it here on the material. Nice, minimum glow. So why didn't I do this whole vector 2? Because I could do that too. I can go here and convert this whole vector 2 to a property. Well, then you'd have a weird thing happening, right? A vector 2 would give you a 0 and a 1. You can't do a maximum glow greater than 100 anyway. So I want to give only the properties that I want the user to modify. I want those only to be exposed. Okay. Excellent. I like it. Right? So far, so good. But I want to be able to turn the glow off. Like, I don't want to always have glow. What if I want some materials not to have glow? Right? Like, I just want it to be on. I want the Fresnel effect, but not the, kind of the in and out effect, where it's kind of like, shading the entire thing over and over again. Right? I want that. I want it to be able to turn it off and on, but just this part, just the glowy effect, right? Just this part. This part here, this part of my shader, this is the emissive Fresnel effect, right? That's what this part is. And what you can do is you can name it. You can kind of right-click this part, the part that you want to keep, and you can go and you can say that I want to do group selection. So this part here, this group, I can kind of make it so that this is the Fresnel effect. That's what that is, right? And what I want, this Fresnel effect multiplies by this, whatever this is, this part here that makes it go. I want this to potentially be on and off. This part. So this part here, right? This part here is the kind of the glow effect, if you will. All right, that's what this is. And the glow effect is going to have a control, right? So before I make a group like this, let's just delete this part. So we don't have a glow. It's always on this way. This shows you it's always on. But I want to turn it on and off, right? And the way to do that is, if I look at, let's say a Boolean, I want a Boolean to turn it on and off. This one. This is my Boolean. This Boolean is going to say it's toggled on and off. So toggle glow on and off is what this is going to be, right? Toggle glow. Okay, and then what I want is another kind of process. So again, you can look at utility here, and under logic, there is a bunch of things. One of them is called branch. Let's grab branch. And what branching does is it takes a predicate, that's this, right? And it takes a value if it's true and a value if it's false. If it's false, I'm going to turn it fully on, like so. If it's true, it's going to glow on and off from here, like so. And now we have a Boolean value, right? And we have a branch, branching. And this branch is going to combine with this up here. So when it's on, it's going to glow like this. And when it's off, it's going to not glow like this. Perfect. And guess what I'm going to expose? I'm going to expose this little Boolean here. So I'm going to right click and I'm going to go to convert to property. And that property is going to be called toggle glow. So rename toggle glow, right? And I'm going to save my asset. There it is, toggle glow. So if I want to turn it on, then I can turn it on. It's going to toggle the glow effect, right? I can also remap other things. Like, for example, I have a time-dependent function. I could multiply my time-dependent function by something else, right, to create a faster glow. Right now, it's going on a very slow pulse. If you want to make it faster, then you take that sine wave and multiply it by a factor, right, and you can make it faster or slower. So let's do that too. So again, let's undo this change here. So time, I want to get rid of that time, and I want to get a variable. So I want to create a node, float. I want to take that sine wave, get it into the variable and take this variable and put it into here, right? Like normal. So this variable here is something that I want to modify. So I'm going to right click here and go to convert to property. And this is going to be the glow speed. So right click, rename to glow speed, right? And save the asset. So right now the glow speed is 0, which means it's not going to glow. But if I increase this to something like 1, that'll be regular speed, right? By the way, you can also provide defaults. It broke from time. It did break from time, right? So what do we do here? How do we take the glow speed and kind of combine it? We want to multiply it, right? So let's get rid of this. And we want to take time and this and create a multiplication. So mult. And I want to grab this multiplication, grab sine of time here, and I want to grab this glow speed here. And I want to take the glow speed. We can also kind of minify these ones like so. Now that we know what the effect is going to be. And then once I have this one, I can take this out and put it inside here. And now we look at a value that's -1 to 1. That's our remap. Be careful, because this can get us higher than that, -1 to 1, because we can reduce that size, right? And it'll go from -1 to 1 to whatever we want, and it'll remap weirdly. So be careful about that. Okay. But now we should be able to remap it. And if I save my asset, and if I go back to glow speed of 1, we should see that it's working again. But I can also do a glow speed of 2. Oh man, what happens there when I do a glow speed of 2? Well, this goes from -1 to 1, right? So now it'll be like -2 to 2, and it'll remap to like, what? Huh? What? 0 to 1 is what it should map to, right? So let's see what the effect is going to be if I did a 0 to 2. And does it do faster? Is it working? Is it going to go below that? What's going to happen? So where you can't see it is not in real time, right? So if I go back to the scene for a second, right, and if I press play, let's see what the effect is going to look like. So this is like twice as fast, right? Potentially. You can see that it's kind of working, right? Okay, and let's change the shader. So instead of a glow speed is 2, let's make it 5. Right? Does that make it faster? Is my question. Okay, how about 10? Remember, this once the shader gets modified, it's gonna modify this right away, right? And it'll stay modified for good. It's not exactly the effect that we want, is it? Stays the same. Absolutely, because we have a clamp value, right? It gets there faster, and it kind of lights up more, right? So it's almost like saturation level more than glow speed, right? Like what if it was 100, right? What's the difference there? Well, it would ramp up really closely and then go away. So there is an effect. It's just a really weird effect. So be careful with this one. Again, let's leave it at 1 for now, and then we'll come back and see if there's anything we can modify to make this a little better. All right, let's go back to the pillar speed, to pillar shader. We have some kind of glow speed, that's what we called it. We multiplied it and we got this, but our remap value goes from -1 to 1. And it's almost like we want to be able to scale this, the remap value. So whatever this value is here, right, the glow speed, is also affecting the Y, right? Because, and this one would be, it would multiply by this one as well, right? So can I produce this multiplication twice? And the answer is I can, right? But the problem with this is once we multiply, and let's see what the difference is here. If I kind of map it twice, I'm mapping it here and I'm mapping it there. So I'm getting my time function, right? -1 to 1, multiplied by my glow speed, mapping in there. That's my thing. So I can do that twice, right? So I'm just pointing this out so you can see what's happening here, right? I'm multiplying it, getting some result, and then that result is going to map to 2 places. What does that do if I do that? So save asset, and let's see, does it make sense anymore? Well, we're getting a black material, right? And we can see that the material here is, we've got a preview, but here we get a black material. Okay. Why? Why is this black? Something broke is the answer. That's why it's black. And it even messes up some other stuff, right? If I make my glow speed something like 2, it won't matter, right? So if I run this thing, you know, whenever we break something, you'll get a weird looking material. Look at that noise we're getting there. That's just noise because we've broken something. Neat. I'm just pointing this out because you can do wacky stuff. Be careful. Sometimes Unity won't stop you from doing stuff because this, my friends, incorrect. Incorrect, right? So what about this? So what about this 0? How can we do it so we can scale whatever we're getting here? -1 to 1. I can set some floats up, -1, multiplied by this thing. Can I output more than one of these? Is that possible? I can, right? So my speed can multiply here, and that's okay. And that's kind of what I want, right? So what about if I had that happen? So I want to take my speed, I want to multiply this, my sine wave, and give me this -1, whatever it's going to be, right? And it's going to give me a range. Instead of -1 to 1, it's going to be scaled according to my glow speed. My glow speed is going to be this value, -1 to 1 times whatever the glow speed is. And that'll give me that range, which we are going to clamp between 0 and 1. That's what this is, okay, 0 and 1. So that's what we want to do. And so what can I do there? If I take my glow speed, I need to multiply it by some kind of vector 2. Let's add a vector 2. And that vector 2 is going to take the place of this thing. So again, we'll go do a vector 2. Here it is. And we'll take that vector 2 and go here, right? And I want to take that vector 2 and I want to multiply it by the glow speed. So this is -1 to 1. Right? There's my -1 to 1. And I want to multiply it by the glow speed. So we'll do another multiplier. Again, it's kind of getting messy, so let's just rearrange some stuff. We can make as much room as we need. Right? It's going to look funny. But let's multiply it by the glow speed. Here's another multiplier, which we can shrink. Right? And we'll get the 2 things. We'll get the glow, whatever that number is. And we'll multiply it by this. We'll multiply in there, and we'll get a value between minus whatever the glow speed is to whatever the top end is, then multiply it by this, which is going to give us the right range to scale everything that we get in here. Poof. Let's see if this works better. Save asset, and okay, that's cool. Does it make it faster? Is it the same effect? What does it do for us, right? Well, let's take a look at the scene. So this is twice as fast now, or supposedly. Let's make it 10 times as fast. Is it going to do the same thing? Is it going to have any effect that we didn't see before? So let's run the scene and see what happens. So again, I don't see it much faster, right? Still clamping at the same rate. And if I go to 100, right? Well, now we see that it's scaled a little bit more, right? But all that's happened now is that actually we've removed the ramp, we've remapped it, so actually it's just the exact same. Do you understand why? Okay, let's go back to this. So if I go back to my shader for a second, yeah, we did all this business and multiplied all this stuff and did this stuff, but what's happening is we're just scaling it, so -2 to 2, and then we're scaling it in here. And then what's going to happen is when we scale it in here, then no, man, right? That doesn't really do the anything for the time-dependent function at all, right? So yeah, this didn't quite work. Nice idea, but it didn't work. We'll think about how to fix it later. But for now, let's just go back to what we had before, which is something that looks like this. All right, so again, you can see the limitations. it's all about imagination, really, at the end of the day, when you start thinking about working with these things and how it looks. So now we have a way of turning it on and off, and we have this whole effect. So this part is the glow. We can toggle the glow on and off. That's what this thing is. So what I want to do is I want to take this whole thing, this part, and I want to put this inside of a box like so. Make sure you don't select anything else other than the ones you want. You can also left shift and basically go to group selection. And we can call this new group the glow effect. There's my glow effect. I can take this and separate it, and now I have two little effects, my Fresnel effect and my glow effect, that I'm multiplying together to get my final effect, whatever that is. Okay, let's apply it, save the asset, make sure that it's okay, right? 100 is definitely not what we want. We want something like way smaller, like 1, right? Well, we can change the glow saturation. Maybe that's going to be called the amount of saturation speed, or something else. It's not really a speed. All right, but what about all the other things? I mean, I want to be able to use my textures for my thing now too. How do I add textures? How do I use a base color? All that stuff, right? Well, I want to have both a texture and a base color. So what I want to do is, there's other things you can do. If I drag from here outwards like this, then it'll make some suggestions. One of them will be, well, what if I want a base color? So if I say I want a base color and I want to multiply it by a texture. So if I let's look at texture first. So texture comes in a couple of different objects. One of them is texture 2D RGB. If I double click there, I'm going to get a texture 2D RGB, but then all I'll get is a texture, no color. So the color will be gone. So I don't just want that. I want to grab my texture, whatever that's going to be, and I also want this over here to give me an option to load a new texture as an input. So I want to say, I want to get a texture input, and I don't want to decide what that is. I want the user to decide what that is. And so this is going to be the diffuse texture. That's what it's going to be. So let's make this into a property. I'm going to call this diffuse texture. That's what that's going to be. And then what I want to do is I want to get whatever that texture is going to be, right? And I want to combine it with a diffuse color. So let's add another color node, which is the basic color node, right? Basic color node. This one. So again, other colors you can add too, right? But I want to do just a base color. I want to convert this base color into HDR. So we're going to have HDR support, right? And let's choose a standard color, which is going to be blue all the way and all alpha transparency on, that kind of stuff, right? Just for now. Or we can also choose a white with alpha transparency 0. So that's going to be our base color. We can add, it's almost like a tint, but that's what our base color is going to be. I want to take this base color, so let's right click and make that immediately into a property. We're going to call this diffuse color, or diffuse base color, whatever you want to call it. Rename. Diffuse base color, right? And we want to take the diffuse base color and combine it, multiply it with my texture to give a tint to the texture if I want. All right, so let's do that. So we'll make another multiply node. And here's my multiply node. Let's just hide that. And I want to grab this, put it in there. And I want to grab this and put it in there. Then I want to take all this and put it into there. And that should give me my diffuse texture. And let's add that, save it. And what happens is you see that it looks like this, just like what we're used to. So there's my diffuse texture, right? Here's my diffuse base color. I can decide to add that in anytime I want. If I want them reversed, let's say, for example, if I want this one to be here, which might make more sense over the other way, then I can just connect them different ways. So I can kind of undo this and undo that and put this one here and put that one there. Okay, see what that does. And if I did save asset, does it make a difference? The answer is no. Okay, so it really depends on how you want this to be organized. I'm okay with it like this, right? And this is your diffuse channel. So this is my, I can call this, I can group this together. You mean in here or here you mean? Yeah, you could. Let's see if I do this. If I move this up there, and if I press on save asset, then yeah, it moves up. Absolutely. But I want to kind of hide this. And if I right click and I go to group selection, I want to call this the diffuse channel. All right. So my diffuse channel is going to be this piece, and I can move it around anywhere I want now that I have it, right? Because this is going to be my texture and my color. All right, how about my normal map? Let's add that in. So it's going to be simpler. I'm just going to go here and add in a texture. It's going to be a sample texture RGBA. There it is. But the type that I'm going to choose is normal. That's important. Tangent space. I'm going to do the same trick I did there with my input. So I'm going to go texture and go 2D asset. There it is. And again, right click, and I want to convert to property. And I want to call this the right click rename. This will be the normal map texture, or just call it normal map. But for me, I'm going to call it normal map texture, so we know what it's kind of in line with everything else we've done. Okay, so my normal map. If I want a color, like if I want a normal map color, so I want a kind of a tint to the normal map, I can do that too, but I'm not going to do that. So here, I'm going to right click, and I'm going to go into group selection. I'm going to call this the normal map channel, right? So that's going to be kind of in there. And then I'm going to save my asset, and I'm going to have that channel in there too. There's diffuse, there's normal map. Let's add them in so we can see what that looks like. So inside of textures, I want to grab the diffuse texture. So that's the D, the A. That's the regular. So you can see here, I've got Stonewall, AO, this displacement, a normal map, and a roughness. So I want to grab this A, which is albedo, and I want to grab it, and I want to put it inside of the, under materials, under pillar material, I want to grab that texture and drag and drop it. Right? So albedo goes here, normal map goes there. And now you can see what it looks like now. It's starting to look more and more like what we want. Okay? Make sense? It should be exciting to you now. You should start feeling, that we make something we can add to something that already exists. We can make our own. This is the first step in making an interesting shader effect. All right, cool. So we've got all these things. We can start moving these things around because we have this and we have this and we have this over here. This is kind of the emissive channel. That's what this whole thing is. So let's select everything here, and this will be right click, and we'll go into now one thing is it says select unused nodes, right? One thing I can't do, notice I can't delete my group and contents. I can't make groups of groups. So I can't do this and this. Can't select both those two things, right? And then right click and do a group of groups. I can't do that, but this is the whole channel. What I could do is if I want to remove the group, again, it's a little bit more work. For now, it's okay. But I wanted to move it down here. That's just the emissive channel. All right, so I have the ambient occlusion. We have an ambient map. So again, I'll do the same thing. I'll do a texture. You can see where I'm going. You should do the same thing now for yourself. So that's going to be the texture. We don't care about this. We're going to combine this with a texture input, which is this. And we're going to make this a property. And that property is going to be called ambient occlusion. So kind of an AO texture. All right, that's what that's going to be, AO texture. right? And that is my ambient occlusion channel. So again, I'm going to go and group selection and say that ambient occlusion channel, right? Again, you don't have to do these groupings, but it just makes it easier for me to identify later, right? When you forgot what you did. Smoothness and alpha and metallic, they're going to be, I'm not going to have channels for those necessarily, but what I may want to have is individual floats. So again, I'm going to make a new float, and this float I'm going to connect to here. I'm going to assign a value of 0 for smoothness. It's like 0.1 for this pillar material, and I'm going to make it so that it is a property which I'm going to call smoothness. What I'm doing is I'm exposing this, right? Same thing with alpha. So this is the alpha channel. Transparency is what this is, right? So again, I can't convert this into a channel by itself, but again, I could do a float like this, and then from here, my alpha is going to be 1 for now, and I'm going to convert it to a property, which is going to be called transparency. So again, you can call it whatever you like, you know, again, and you can rename these after too if you don't like me. So transparency. So transparency is there. And the last one is metallic. So again, same thing, float. And my metallic, I want to make that like really low, like 0.1. And my float is going to be converted to a property. And we're going to call this metallic. Rename. Okay, cool. And now let's rearrange these to make more sense of them. So AO texture and all that stuff, these are other properties we don't as much care about. That's why I've done it this way. So we have textures here and properties down there, and that's pretty good. All right, let's save the asset and see what it gives us. It gives us another space. We can take our ambient occlusion texture and drag it in. Okay. And we have some default values for metallic and smoothness and transparency. If I wanted to make it semi-transparent, I could, but I'm not going to do that. And I'm going to press save. And let's see what it looks like in the scene now. It's not bad, right? You can't see the object behind it. Look. See, object behind, can't see it. But you can see a nice looking view in terms of our normal map and the way it looks. It's pretty good, right? We can get rid of that cube now. And what about the glow effect? Does it actually work in the on the game? Let's see how it works here. If I'm checking it here, right now it looks like it's kind of going in and out. There it is. You can change the values to make them more dramatic if you want, and that's pretty good. But how about, does it even build? Does it even do this thing? Does it work on our device? This would be all a waste if it didn't work on our device at all. Right, so that's kind of a thing we need to check next. But first, let's put this down on GitHub, file, save project, and close this off. And then what we're going to do is put this up on GitHub. So this will be the added, you know, kind of a pillar shader to shader graph, through shader graph. So again, going here, we're going to go and clear git add dot git commit -m, and we'll say added pillar shader through shader graph. So we know what we did. Git push. And when we did that, we added the universal render pipeline. We could have done other commits here. I could have done one for converting to the universal render pipeline. I could have done another one to, you know, when we converted all of our assets. I could have done another one, you know, and so on. There's like lots of them I could have done. I'm just saving some time here by doing this piece. All right, and now let's go back up. So how are you guys feeling? A little bit more comfortable now with shader graph? There's so much you can do, guys. Shader graph is so creative with the stuff that you can come up with, right? And there's limitations too, all right? Remember that a lot of stuff that you're seeing us do is on the fragment shader, all right? We haven't really touched the vertex shader yet. the fact that they exposed it is awesome. They didn't even have it exposed before. And we're going to get more and more really cool stuff happening with shaders. And like you can see here, there's 0 to no code. It just has you understand how that works. That's all it does. Okay, pretty cool. Let's make sure that this works in a regular scene. So I'm going to go back to scenes, and I'm going to go into main in here, and let's grab the pillar in our level. So the two pillars, pillar 1 and pillar 2, more or less, they use the old pillar material, which is the Autodesk interactive material. Let's change that up with our own pillar material now, right? And we can see that in the scene. We can see it now here. Nice. I want to save the scene. Getting pretty hot here, right? And I want to convert now. I want to build it, and let's just build it straight to the device or your emulator, whatever you feel comfortable with. I'm going to go right to the device because I've already went to the device once, and let's see how that looks like. So file, save project, and then I'm going to do a build and run. Build and run. Now this is going to be building with the universal render pipeline as well as the new shaders we made. And if this works, any of your own in your speaking out here for a second. So I'll stop talking. And see better. My RTX 3070 is like, it's at 87 degrees right now. As it kind of fired up, so yours should be like roaring. And it's collecting the binary now. We're getting closer. And we should see it's building the Grado project. I'm just going to bring this up right now so we can start seeing what this looks like as it converts. Right? And here it goes. All right, we can look at our map. It looks like our URP is working great. And if I look at my shader, it's right here. Is it glowing? If it glows, my friends, and well, the fact that I can even see a texture on this on this thing here is great. There you go. That's proving right there that it works. And at the same time, we see that our zombies are really angry at me, and they are going to attack me. And they're using the lightweight issues, but we can see issues. And some of the issues that I see immediately are this. You can see the pixelation here that's happening in the shadows, right? That's something we can improve on. That's something we would have had before too. We actually even have that in the scene right now, live. So this is something we can fix. Slidey feet, this animation is not the best when it comes to the way they attack and stuff. It's kind of weird, right? Kind of moves forward, but the feet kind of slide around. And some of the reason why we have slidey feet is because we're billboarding. Okay? So kind of interesting, but it works. The idea here is that it works. Okay, that we loaded the the URP and it works just great, right, with our scene. Not really bad performance, right, overall. So I can report a really easy build, and we're using again 2020.2.1 F1. Sure, it'll probably build with 2021. I've been testing 2021 lately as well. It looks pretty good so far. All right, so awesome. That's great. But how about that shadow? What is wrong with that shadow? One way you can do is test it here. If we have a shadow problem in here, like that's kind of like really weird looking. We looked at this before, right? Look at that terrible shadow right now that we're having here in our device. It's really, the anti-aliasing is really bad. And this is like a probably a projection artifact, or it's not perspective, it's a projection-based problem, right? So let's take a look and see how we can fix that. And that it could be under quality settings. So again, one of the things we created was these URP assets in here. One of them is this one, which is in the anti-aliasing. So anti-aliasing right now is disabled. HDR is enabled. I'm going to warn you, when you turn anti-aliasing on a device, just worried. Let's put it to at least 2 times, okay? Trying to make this higher on a mobile device can be bad. Let's put it that way. So that's the first thing. Anti-aliasing's got to turn on. Let's see how that affects things as it is. This is the pipeline, right? So how does that look now? Is that any better? Still pretty rough, right? Look at that. That's like pretty rough. What about if we move to 8 times anti-aliasing? So again, I go back, move to 8 times anti-aliasing, and we look down, and it's a bit better. That looks okay over there for the shadows, but the shadow map right here looks pretty rough. Okay. Shadow resolution is this. Cast shadows. Additional lights are per pixel. Shadows maximum distance. That tells you what that is. The cascade. We only have 1 cascade, right? There's also some things we can do. We can turn soft shadows on. Be careful. Once I start increasing these values, then all of a sudden our performance will go pew and drop, right? Let's see if that is going to make any more sense for soft shadows over hard shadows. Remember, we have a lot more control now with the universal render pipeline. That looks a lot better, right? But, what soft shadows does is it really, kind of, it has a blur that adds on to our scene. You can see that still it's not so bad, and even the distance over here with a cascade of 1 is pretty good, right? So 1 cascade means that like we don't have from a cascading shadow maps perspective, it's not so bad. Here it's kind of glittery. You can see that over there we're getting a little bit more problems. It's problematic over there. How about the maximum distance? So if I increase this value to something bigger, the working unit is metric. That's okay. Cascade count. Let's go to 2 cascades. So if I was to move to 2 cascades, it does an automatic shift. But you can decide how far the second cascade is. We can bring this much closer in. Right now it's 12.5 meters away from the character. That's where all the detail is. Anything beyond 12.5 meters is in the second cascade. What cascades do, again, is we don't care about shadows that are further out, right? So shadows that are further outside of where we are, cascades allow us to say that we're going to have a level of detail that's closer, that's higher level or higher resolution as we're closer to the character, the view of the camera, compared to farther out. We can also mess with depth bias, and if you look at what that is, it says controls the distance at which the shadows will be pushed away from the light. Useful for avoiding false self-shattering artifacts, right? And normally it's a 1. Self-shattering artifacts is pretty good. The other one is normal bias. It controls the distance at which the shadow casting surfaces will be shrunk along the surface normal, and useful for avoiding false self-shattering artifacts. Again, so these are just like helping us reduce artifacts. The split, it talks about how many splits. And if I increase soft shadows, it increases the, kind of what I'm doing in terms of the amount of, it increases the memory, kind of computations as well. All right, so this is good. Yes, I agree. It doesn't fix the problem, it just hides it. But it's okay for us to hide the problem. It's better than what it looked like before, right? So that's pretty good. Post-processing, we're not going to touch right now. It uses low dynamic range for grading mode, and we can use high dynamic range, but I wouldn't recommend this for a mobile device. Okay. Mixed lighting, that means both real-time and baked. It'll accept that as well. And we have a lot of control here. You can see that there's tons and tons of stuff that you can add in here as well. Okay. We may want to move this value from 8 times back down to 2 times again. And I want to show you the difference. There's not much. 8 times is huge in terms of a performance hit. So guys, be reasonable. That's pretty good for 2 times. So we want to optimize. We don't want to make it worse, right? So for the most part, most of the shadows are going to look really good with soft shadows. Like Russ said, it will hide the problem, right? Slidey feet's not going to go away because of that. All right. So this is okay, but we don't need that. Opaque texture. A lot of times we use opaque and depth textures to, if you want to access them. We're not going to do that right here. We're not going to turn those on. Extra additional lights. Right now it's per pixel, and per object limit is 4 lights. Again, usually that's a pretty good idea. Why? Because we're using a forward renderer. We're not using deferred rendering, and most of the times deferred rendering on a mobile device or even on WebGL either is not supported or is very bad, right? So from a performance perspective. So that's this asset. What about this one? So this one says, okay, I've got my forward rendering. I want to transparent receive shadows. I can do overrides for stencil, my stencil shader, and I can have my opaque layer mask, which right now is everything, and my transparent layer mask, which is everything. You can adjust those again for performance reasons. So those 2 things are really super important. Also under project settings, if we look at under project settings, and you can see that our light map modes is automatic, fog modes automatic, instant scene variants strip unused. We can also create logs for shader compilation if we want to. Really good. Lots of extra stuff with the URP. The other thing is quality. We go back to quality. Right now, from a mobile device perspective for Android, we are at medium quality. Medium quality is the default. What medium quality gives us is texture quality is full res, right? As an example, notice that a rendering, it says none. We can choose a rendering pipeline. I recommend it. So we can choose the universal render pipeline asset for this, for our quality, okay? Why? Because our rendering will go through this before it gets any adjustment, okay? Distance shadow mask is pretty good. And all these different things, we put in 2 bones for skin weights. And again, that reduces the quality of our animation, but that makes sense, right? VSync counts is every V-blank. That means, remember when we talked about this in our, if maybe you guys didn't in Alex's class, when you did fundamentals, game fundamentals, we talked about V-blank in game fundamentals and how it clears the screen over another. It's kind of a screen refresh, effect. Maximum level of detail level. Now, if I want to, I can skim this up to high. Some devices will take it. So if I move from medium to high, I can just choose this little line here and go high. And if I choose high, you can see the effect of it, right? So again, let's connect to a universal render pipeline asset, and we'll see the differences, okay? All right, that's one. The other thing is tier level. So again, we talked about this from a graphics tier. Right now, we're at graphics tier 3, locked. I'm not in the other tiers at all. let's go to player settings one more time. So player settings. And if I go to resolution and presentation, you can see that my resolution scaling mode is disabled, right? And I want to keep these settings. I'm not going to modify them. Start in full screen mode for sure. Other settings, right? Again, I'm using OpenGL ES3 is what I'm hoping to use, not the other ones. And you can see that what's been turned on is nothing that we've touched before. Okay, so everything else is the same. Just looking for anything else we can improve. I don't think there's anything else that I want to touch right now. Okay, let's try it one more time. Let's try, kind of putting this out and see what the effect is going to be. One thing to note is I want to check it here again one more time. So this is inside of my simulator to see that we're going to be okay with what we're seeing. That's really good, right? Now, again, there might be a difference between what we see in the simulator and what we see on the device. Why? Because remember, the simulator is using my desktop and the device is going to be my my device, right? All right, cool. So let's stop this. Looks like it's pretty good. We've made some adjustments. Let's go File and Build and Run. And there's not a big platform change. Let's see if this is going to be better. Okay, let's see. Yeah, we didn't really consider the inequality settings. That's why when I linked them together, because I forgot to do that. Otherwise, you're going to have kind of poor quality settings. But I'm really looking for what the effect is going to be at the end, right? I mean, who cares about all those settings if it doesn't do anything, right? What we want to see is what it looks like on the phone, on the final version, which is kind of the way to go, or on your emulator. Emulator is going to look pretty good, but what it looks like on the phone is the key. All right, well, let's look what it looks like. That's really good, guys. Look at that. That is awesome. Good shadows and everything else. That's really good. Let's see what our little shader did in terms of our way it looks. Look, that even looks better now with the shader and everything else. So really cool stuff, right? Solid. And it's working great. I don't have any degradation in performance at all with these two guys. I'm not getting a frame hit at all, it looks like. At least the feel of it doesn't look like it, right? Again, you might get some pixelation here because I'm actually casting from my phone, but how it looks physically on the phone itself is really high quality. It looks great, right? In 3D. So imagine if I can do this in 3D, what it would look like if I was doing a game in 2D. I'd have a lot of really cool control and, again, access to all those shaders that I can put in place as well. All right, that's it for today. For your lab, what I'm looking for is improve the quality settings of your game, right? We've talked about some additional settings that you can use to improve quality for your game, as well as to make your game pop in terms of unique looking shaders and those kind of things. I encourage you to explore additional shaders and things that you can add into Shader Graph, right, to make it even better, even nicer than this. Some really cool things you can look up are things like, if you look up Shader Graph, there's some really cool things like if you want to add in these kinds of effects. All of these type of effects for characters in the game are supported, right? It also does some built-in textures as well as noise, all kinds of noise effects, scrolling textures. It also helps you with things like displacement, volumetric clouds. All those kind of things can be created with Shader Graph to create the weather effects that you want in your game. I highly encourage you to go through some of these videos and other tutorials online that can give you things like portals, water effects, and a bunch of other stuff right through the Universal Render pipeline. Okay, that's it for me for today. Any questions? Yeah, so I made one screenshot of your shader graph, one screenshot of the actual asset in the game, you know, whatever that asset's going to look like, and I think that's pretty good. And that's it for me, guys. I'll stop recording this one. Any questions?